Welcome to our review on electrolysis of brine. So brine is a concentrated sodium chloride solution, and when we carry out electrolysis on it, we generate three products: chlorine, hydrogen and sodium hydroxide solution. However, in order to actually carry out this process of electrolysis, we need large amounts of electricity, which makes this process expensive. So remember, electrolysis is the splitting of chemicals using electricity. So when we're using electrolysis, what we need to make sure is that the electrodes that we're using in our electrolysis setup are made from an inert material. And the material we tend to use is titanium. Now, inert means it's not going to react with things easily, which is very important when we're talking about the electrodes, because they're obviously in the tank, and if they react with things, then they're going to wear down quickly and need replacing frequently. If we use an inert material like titanium, then the electrodes won't react with the salt or any of the products from it, and therefore they'll last a long time. And anything that we can use in terms of our machinery that's going to last a long time is going to reduce the costs for us. So if we look at how electrolysis happens in a little bit more detail, what we've got are two electrodes. One's positive, the other is negative. And we do need to remember the names and which one's positive and which one's negative here. So we've got the positive anode and the negative cathode. And the way that I always get my students to remember it is, think of the grumpy cat. He's very negative about most things, so a negative cathode. Now what we find is chlorine, when it's actually in ion form, has a negative charge, so it will be attracted to the positive anode. So what we find is chlorine forms at the positive electrode or the anode, and hydrogen, when in ion form, is H+ ions, and therefore it's attracted to the negative electrode, the cathode, and that's where we get our hydrogen gas forming. Sodium hydroxide just stays dissolved in the tank. What we need to remember then is the difference between oxidation and reduction reactions. And the easiest way to do that is to remember oil rig. So all oil rig stands for is oxidation is the loss of electrons, reduction is the gain of electrons. We can also think of that in terms of oxygen. So oxidation is the gain of oxygen and reduction is the loss of oxygen. So remember our oxidation and our reduction. Now if we look at sodium chloride in terms of the ions found within the solution, we've got Na+, which is our sodium ions, Cl- chloride ions, H+, hydrogen ions, OH- hydroxide ions. So what we actually see happening at the anode then is our chloride ions lose electrons. They are oxidized to make chlorine gas. So what we see is our two chloride ions, so 2Cl-, we lose the electrons, so -2E-, because E- is our symbol for an electron, and that gives us our chlorine gas, Cl2. Remember that chlorine always goes round as that little pair of gases, okay? At the cathode, what we see is our hydrogen ions gain electrons, so they're going to be reduced because reduction is gain, and that means we make hydrogen gas there. So we've got our two hydrogen ions, 2H+, we add 2 electrons, 2E-, and as a result we make hydrogen gas, H2. The remaining sodium and hydroxide ions will join to make sodium hydroxide, which has the formula NaOH. We do need to know how to test for chlorine. So chlorine itself is a gas which has a faint yellow-green colour, and when we dissolve chlorine in water we make an acidic solution. And if you've ever managed to get chlorine on any of your clothing, then it has the ability to bleach dyes. Now the way we can test for chlorine is using this stuff called blue litmus paper, and if we have moist blue litmus paper and we hold it over chlorine gas, then it first of all turns red and then it goes white as it's bleached. So remember that little test for chlorine gas, that moist blue litmus paper goes red, then white.